Hello everyone, this is LeetCoder. Today I'm going to talk about another algorithm problem from LeetCode. And the question is valid parentheses. So here's the question, and you can take a look at it, and I'm gonna have it open on the right side of it. But basically what we need to establish is closing up the parentheses correctly. So this case and this case is correct because it closes successfully, but this one doesn't. Well, it's a different parenthesis. So we have to close it up with the same one. And this one is incorrect as well, because if there's a parenthesis that starts with this, then it should end in between those two, which you may call it some bracket. So if there's a bracket inside another bracket, I should say, then they should all close up. This problem is quite complicated, I think. It's not, well, it could be easy, but it's really not easy for me. But I can't think of a way to solve this. And there's a translation here for my Korean subscribers, and I'm going to post, which may call it a subtitle, so you can take a look at it while, I guess, spectating how I approach to this problem. But there's going to be a base case here. So if s count must be greater than 2. Probably you know why at this point, because the bracket has to close up, and in order for it to close it up, it needs at least 2. So if it is smaller than 1, it is obviously wrong. So we just return false. And I'm gonna create an array called stack that will hold characters inside, because each bracket is also represented as character here. And I'm gonna use the for loop to loop through every string. Not every string, just one string, and check each character inside this string. So first thing I'm going to check is if character, the current character, is the closing bracket. Oh yeah. Then we just append it to the stack, because we want to keep track of what has to be closed, I guess. Right. And that is the way how I'm gonna start. So if this is the case, if the bracket is the starting one, so the opposite is going to be like that, then we put it in the stack. If it is the closing one, well, append it first. Then we check if the stack count is greater than 0, because it's the closing one and we need more than 1 in the stack to tell that there's a bracket that can be closed. More like there was a starting bracket in the get-go. So here it's checking if stack count has, well, not stack count, if the stack has characters like this. If not, then we simply return false. Inside here, what we're gonna do is we're gonna remove 1 from stack, the last one, because we have to compare if, which may call it, it can be closed with the same one. So let me show you how I would go about using this current one. If the current is equal to this type of bracket, I think it's called curly braces, then we have to check one more time if the current char is this one. If so, it's not this one. If the current one is this one, then the character that we should have right now should be this one. And if it is not, we should return false because it is different bracket, and that is simply wrong. You know, in the example, bracket should close up like this. If it is like this at this point, it means it is wrong. And basically that's what I'm gonna do. I'm gonna have a bunch of if-else statement that will find the corresponding character, and if they do not match up, then that means we can just simply return false. And there are a total of 3 different brackets, so we can just close it up with the else statement here. And then I'm gonna remove the comment because it's unnecessary. And at the end, we're gonna check if the stack count is 0, because it has to be. If it is not 0, that means we have 1 or more existing brackets that were not closed up. So if it is greater than 0, that means it is false. If not, if the stack count is 0, then it is true. This algorithm should be not relatively, but pretty fast. I tried a lot of methods and some of them failed, as you see. And this one I think was a simple method, but I just wanted to share the optimized version because simple version is basically similar in a way, but I used dictionary in it. But you know, why share something that is worse than this current algorithm, I guess. And yeah, you know, if it is necessary, if the other solution was much easier than this one, I will share that one just to show you how I solved it first. But the first solution that I came up with was not as easy as this one. It could actually look relatively harder than this one, so I didn't want to share it. But here's the solution, and if you have any more questions, please do not hesitate to ask me. Thank you for watching. Please hit like and subscribe. See you in the next video.